All right, for our second mini lesson is to learn about Pythagorean theorem. So the Pythagorean theorem is really important in finding the missing sides of right triangles, and it'll come in real handy when it comes to trigonometry. All right, so the Pythagorean theorem comes from Greek mathematician Pythagoras, and he came up with the following. He noticed this relationship when it came to right triangles, that in a right triangle, the sum of the legs squared is equal to the hypotenuse squared. So I'll let you get that down. So in a right triangle, the sum of the legs squared is equal to the hypotenuse squared. So just a reminder, when it comes to a right triangle, here's your right angle, that the legs are the two sides that meet to make the 90-degree angle, and the hypotenuse is the side that's opposite the 90-degree angle. Okay? And what he noticed is that if you take a right triangle like that and you square its side, so let's say this side is 3, and you take 3 squared, that gets you 9 squares, right? 3 by 3 gets you 9 squares. And if this side is 4 length, 4 squares, then this side is 4, and that side squared would give you 16 squares. And this side here being 5 squared gives you 25. And what he noticed is if you take those side lengths, 3 and 4, if you take those legs and you square those, so 3 squared giving us 9, 4 squared giving us 16, and you add those two together, it ends up equaling that hypotenuse side squared. So if you notice, 9 plus 16 does equal 25. And that's the relationship that Pythagoras noticed. So just to answer these questions over here, what's the area of the smallest square? We figured out that was 9 because 3 squared equals 9. The area of the bottom square, which was that square here that had a side length of 4 and 4. So the area of that square, 4 squared gives us 16. And the area of the largest square, 5 times 5, or 5 squared equals 25. And so the relationship that he noticed was that if you square the two sides of the legs, it'll equal the hypotenuse squared. So when we use letters to represent the legs, we always use A and B, and then C always represents the hypotenuse. So what that means is that the Pythagorean theorem's formula is A squared plus B squared equals C squared. The square of one of the legs plus the square of the second leg, add them up, and they equal the square of the hypotenuse. So A and B are the legs. Sorry, I gotta hold my paper. Easier said than done. And C is the hypotenuse. There. So A and B are the legs, and C is the hypotenuse. So with that, so just to make, I'm just going to write out a little sentence out to the side here. You might write it as I'm saying it. I'm sorry, my handwriting's going to be rough with this. In any right triangle, with legs of lengths A and B, a hypotenuse of length C then A squared plus b squared equals c squared. That's what the Pythagorean theorem states. So anytime you have a right triangle that has legs with lengths of a and b and a hypotenuse that has a length of c, then this formula will always hold up to be true. A squared plus b squared equals c squared. And you will use that a ton throughout your life in mathematics. All right, now the converse of that is then if a triangle, sorry, I'm just drawing a triangle to keep myself from writing too much, has side lengths of A, B, and C, and we know that a squared plus b squared equals c squared, then the triangle is a right triangle. So it's basically saying it's a way to prove whether a triangle is a right triangle. Is if it's two legs, if two sides squared added together equals the third side squared, then yes, it is a right triangle. So it's just a way to prove that it's a right triangle. And the actual Pythagorean theorem is if you know it's a right triangle and the two legs that make the 90-degree angle, if you square those and add them together, then they will equal the hypotenuse squared. Okay? So that's the gist of the Pythagorean theorem. We're going to go ahead and use that to solve some problems. All right, so we'll do some together, and then I'll assign word problems for you to do as your assignment for this. All right, so we may not do all these example problems. We may just do a few, and you can get some extra practice if you want with the others. All right, it says find the missing side lengths for each right triangle, round to the nearest tenth. So on this problem, you're given the two sides of the legs. So now with these, it doesn't matter which one you label A and which one you label B. The only one that matters is your C has to be the side that's the hypotenuse, that's across from the 90-degree angle. So always get in the habit of writing out your formula, a squared plus b squared equals c squared, and then plug in what you know and solve for what you don't. So a is 4, so I'm replacing a with 4, so that's 4 squared. B is 8, replace that. And C we don't know, so we leave it as C. And don't forget, it's c squared up there. All right, 4 squared, sorry, I'm gonna sneeze. Maybe not. All right, 4 squared is just 4 times 4, so that's 16. 8 squared is 8 times 8, so that gives us 64. Keep bringing down everything else. 16 plus 64 is 70. That's not right. Oh, that's why I mistyped it. It's 80. So 80 equals c squared. Now, once you get to this point, our goal now is, now that we've simplified this left side, we want to get c by itself. We don't want our answer to be c squared equals 80. We want to find out what c is all by itself, not c squared. So what you have to do is you have to take the square root of both sides. So that becomes c. And then we got to find out the square root of 80. So you just type into your calculator, use the second button, and then the square root, and then type in your 80 and enter. Oh, my calculator's got to be picky. Okay. Wow, is my calculator old? All right. Oh, and it does that. It doesn't give me a decimal. So once you, and I can't switch over right now. 1 second. And I don't remember on this old calculator how to make it into decimal answers. So what I would want you to do is just use your